Alright, good day everyone. So welcome back to my YouTube channel, and we are now in integral calculus. So this is Kasalikan Vlogs, and we're going to talk about integral calculus, introduction and the basic integration formulas. So this is the first topic about calculus. So we are going to introduce what calculus is and so on. Okay. So, anti-differentiation, the inverse process of determining a function whose derivative is known. So take note, we are done with derivative. So today we have now the anti-differentiation. So the required function is called the antiderivative. So in other term, anti-differentiation is what we call as the integral of, or the derivative, the anti-differentiation or the integral of. So that's it. So we have here the theorem, two functions f of x sub 1 and f of x sub 2 that have the same derivative differ at most by the constant. So this is the theorem that we're going to focus. So example, we have, if we're going to take an example for this part, okay, like this. Okay, so if this is okay, this is the theorem. So if this is x cubed plus 4 and this is x cubed plus 3, if we're going to take the derivative of this one, this would become 3x squared, the derivative of this part. And if we're going to take the derivative of this part, we have here 3x squared, right? So they have here 3x squared, so the same derivative, but differ at most by constant. So differ lang sila sa constant. So if we're going to take this, because the derivative, the inverse process of derivative is the integral or the anti-differentiation. That's why if we're going to take the integral of 3x squared dx, so the result of this one is x squared 2 plus 1 over, this is 2 plus 1. So since we need to have, this is just the inverse of the antiderivative, so supposed to be we need to get, or we need to produce 4. Since the derivative of a constant, we take the derivative of a constant, we could not take anymore back the 4 here. That's why ang maging mangyayari dito ay so maging plus c. So this will become 3, cancel this part. So this is x cubed plus c. Same here, if we're going to take the derivative, the integral of this part, so we have here x cubed plus c. So take note, this c is the constant of integration. So differ lang sila most by its constant. So that's it. That is what we have to determine by this one. So we have your 3x squared. So ang naging part ng constant, naging c siya. All of the constant becomes c. So here, c and c. That's why the function have the same derivative. Their difference is a constant. Thus, if we let c be any constant, then we may write x cubed plus c as our general answer. So take note, all of our general answer would have plus c. Take note of that. So since these are the constants, so the constant will serve as our c. So in this form, integral of f of x dx is equal to f of x plus c. So this is what we call as the integral sign. And this is the integrand. This is the particular integral. And this is the constant of integration. So take note, this dx means to say this is determination, this would determine what what variable that we're going to use. Okay, so itong dx would determine that the variable of integration is x. Okay, so f of x plus c is the indefinitive integral of f of x. So that's it. So let's have basic integration formulas. So the basic integration formulas, we have I1 to 5. So I1 to 5, I is equal to the integral of du u plus c. And next we have integral of u plus b dx is equal to the integral of u dx plus v dx. Alright. And we have I3, we have integral of au dx, so the constant here. Okay, extract the constant. Okay, out. So in I4, so this is the mostly na ginagamit ito, u n plus 1 over n plus 1 plus c, where n is not equal to -1, should not be equal to -1. Why? Because it will become, okay, paano paging, because hindi siya pwede. Okay, undefined siya. So I5, integral of du over u, that is ln of u, the natural logarithm of u plus c. So take note that formula I2 can be extended to sum of any finite number of differentials. So I2, so we could extend this part. And I3 tells us the constant may be removed across the integral sign. So this is the constant may be removed, may be moved across the integral sign. And I4 is the use of finding the integral of a function, power of a function, note that holds any real number and except -1. Note that further, u is equal to x. Dapat u is equal to x like this, x squared. So dapat u is equal to x. So if that is x plus 1 squared, the u is now not equal to x. So iba na siya na solution. Okay. Dapat, if we're going to make use of this part yet, so we have to process that u is equal to x. Okay, so we have here the basic integrations. So we have here number 1 is the integral of 5 dx. So we have number 1. So how to take the integral of 5 dx? Okay. So we have here number 1. Okay, number 1. So integral of, this is number 1, 5 dx. So we could determine that the variable of integration is x. So we have here, by the use of I4, so 5, this is x raised to 0, right? So x raised to 0 is equal to 1. That's why, since the variable of integration is x, we put here x plus 1 over 0 plus 1. So since the general answer should have plus c for all constant, so therefore the answer is 5x plus c. So this is the answer. So take note, it should have plus c. Okay. So the general answer should have plus c. Again. Okay, next number 2. So we have in number 2, we have the integral of 4x plus 5 dx. Okay, so 4x plus 5 dx, we have, since if we're going to apply, okay, so integral of 4x dx plus the integral of 5 dx. Since we could apply that, we could move the constant, so we have here 4 integral of x dx plus 5 integral of dx. Okay, so since we can now integrate, so we have here 4 by the use of I5, I4 rather, I4. So x 1 plus 1 over 1 plus 1. So we can have this one as plus c, right? C1 plus 5. Okay, x0 plus 1 based on the illustration a while ago plus c2. So we could have this one as 4 x squared over 2 plus c1 plus 5x over 1 plus c2. Okay, since this c and c, we could simplify rather by using just like this. So 4, okay, so x plus 1, 1 plus 1 over 1 plus 1, then plus 5x raised to 0 plus 1 over 0 plus 1, then the over big C, because it's stated that constant can always be combined into a single constant. So we could combine the single constant here. So RC here, RC is equal to C1 plus C2. So our big C becomes, we combine C1 plus C2, that is our constant, our big constant, naging big siya, constant natin C. So we have here 4x squared over 2 plus 5x. So we have here 2x squared plus 5x plus c. So take note, okay, plus c. So do not forget to write plus c because your answer is wrong, because it should be a general answer. Okay, next we have number 3 rather. Okay, so we are now in number 3. So in number 3, we have the integral of x times the square root of x minus 1 dx. Alright, so we have here, we could simplify this. X times x raised to 1/2 minus 1 dx. So integral of x raised to, this is 1/2 plus 1, the exponent is 1 here, so we have here 3/2 minus dx, the integral of here x dx. So by the use of I2. Okay, so next we have here the integral of 3/2 dx. So you have x 3/2 plus 1 over 3/2 plus 1 minus x raised to 1 plus 1 over 1 plus 1, then plus over all c. So this is x raised to 5/2 over 5/2 minus x squared over 2, then plus c. So we could take the reciprocal, so we have here 2 over 5 x raised to 5/2 minus x squared over 2 plus c. So now we could have this one as 2 x raised to 5/2 over 5 minus x squared over 2 plus c. Again, do not forget to write c as a general answer because we are now in integral. Okay, let's proceed with number 4. The problem for number 4 is integral of 3x squared minus 5 dx. Okay, so here integral of 3x squared dx, okay, minus integral of 5 dx. So 3 integral of x squared dx minus 5 integral of dx. So we have to do it step by step so that you could be able to understand. Okay, how did we come up with this? So paano ito? So we have here 3. Again, this is x2 plus 1, then 2 plus 1 minus 5. Since the variable for integration is this, so this is x0 plus 1 over 0 plus 1, then plus c. So we have here 3x cubed over 3 minus 5x plus c. So cancel this part. We have here x cubed minus 5x plus c. So this is the final answer or the general answer for this integration. Okay, so that's number 4. Let's proceed with number 5. In number 5, the problem for number 5 is the integral of 6x squared minus 4x plus 5 dx. So we know that the variable of integration is x. So integral of 6x squared dx minus integral of 4 dx, 4x dx, this is x, plus integral of 5 dx. So move the constant. So we have here x squared dx minus 4 integral of x dx plus 5 integral of dx. Since we know already that the integral of a constant, just add it by the variable. So we have here 6, we have here 2 plus 1 over 2 plus 1 minus 4. This is x, 1 plus 1 over 1 plus 1, then plus 5x. Understood? Because we solved it a while ago, plus c. So this is 6x cubed over 3 minus 4x squared over 2 plus 5x plus c. If we're going to simplify this, okay, simplify, this is 2x cubed minus 2x squared plus 5x and plus c. So do not forget to write plus c. Alright, that's number 5. So let's proceed with number 6. The problem for number 6 is the integral of 2x squared plus 4x minus 3 over x squared dx. So in this case, since this is a tricky part, we could move that one into numerator, into the numerator side or the upper part of this fraction, numerator. So integral of 2x squared, better here to move it up. Then this will become x raised to negative 2 dx. Alright, so if we're going to combine this, if we're going to distribute, so integral of, so this is 2x2 plus negative 2, right, by the algebra, 4x raised to 1 plus negative 2 minus 3x raised to negative 2. Then we have dx. Okay. So, okay, ating kunin pa ito kasi lahat ito ay may dx. So we have here 2 raised to x. This will become x raised to 0. So integral of 2 x raised to 0, that is 0, plus 4 x raised to negative 1 minus 3x raised to negative 2, then dx. If we're going to simplify this, the integral of 2 plus, we could have 4 over x minus 3 over x squared, then dx. So this is now the simplified. So now we could now take the integral of this part. So integral of 2 dx, move immediately, plus 4 integral of dx over x minus 3 integral of dx over x squared. Integral of the constant, we have 2x plus integral of dx over x, that is equal to ln x. So this is 4 ln x. So if you can see dx over x, that is equal to ln u plus c. So this is the variable of integration is x, so that is ln x. Plus, we could have this one is minus rather. Alright, so we have here minus 3. We could have integral of x raised to negative 2 and plus 1. Then this is negative 2 plus 1 dx. So we have here 2x plus 4 ln x. So this is negative 1. So this is negative 1 and this is negative 1. So negative, negative, they become plus 3 over x plus c. Why naging over x? Because negative 2 plus 1 is equal to negative 1. So simplify, we have over x. So the final answer is 2x plus 4 ln x plus 3 over x plus c. Alright. So that's the final answer for number 6. So let's proceed with number 7. In number 7, we have the integral of x cubed minus 8 over x minus 2 dx. So we could factor this one by the use of your algebra. Okay. So we could factor above part or the numerator part. So we have x minus 2. This is x squared plus 2x plus 4. Alright. Over x minus 2. So take note of this. This is a factor of this x cubed minus 8. So we have dx. So cancel. Oh no, that is not included here. This is cancel. The integral of x squared plus 2x plus 4. And this is dx. So integral of x squared plus 2 integral of x dx plus 4 integral of dx. So since we have to integrate this one, this is x2 plus 1 over 2 plus 1 plus 2 x1 plus 1 over 1 plus 1 then plus 4 x plus c. So understood, this is constant. Okay. So this is x squared, x cubed over 3 plus 2x squared over 2 plus 4x plus c. So we have here x cubed over 3 plus x squared plus 4x plus c. So this is the result for number 7. Alright. So now let's proceed with number 8. In number 8, right now number 8, alright, this is the square root rather. Okay, the square root of x raised to 4 minus 2x cubed plus x squared dx. So the attempt that we're going to do here is we need to factor. Okay, so integral the square root of, since the common of this part is x squared, right? So this is x squared minus 2x plus 1 dx. Okay, so we could simplify, or we could still form this a product or factor this part. So we have here the integral of x squared, then this is x minus 1 squared dx. Okay, so we could now take the square root of the side and the square root of the side. The result is the integral of x. The square root of the side, it will come here and here. So this will become x minus 1 dx. So we have simplify x squared minus x dx. So integral of x squared dx minus the integral of x dx. So since integration understood by the use of this one, this become x cubed over 3, right? Minus x squared over 2, then this is plus c. Okay, understood that this is add 1 and add here 1 also, and 2 that is equal plus c. Okay, so let's proceed with 9. Okay, so in number 9 we have 4x cubed plus 2 over x dx. So first thing that we're going to do is we have to, alright, we could say a pattern here. So we have integral of 4x raised to negative 3, then plus 2 over x dx. Okay, so we could have this one as 4 integral of x raised to negative 3 dx plus 2 dx over x. I did not raise here because we could form logarithmic here. Okay, by logarithm. So 4, we have x raised to negative 3 plus 1 over negative 3 plus 1 plus 2 ln of x plus c. So again, this is ln x. So we have here 4x raised to negative 2 over negative 2 plus 2 ln x plus c. It could not be raised because that would make undefined. If we will raise to negative 1 plus 1, the negative n should not be equal to negative 1. That's the statement. So that's why we use of this one, dx over x. Okay, again, kung gamitin natin ang yung same here na erase natin ang negative 3, it could not be because n is not equal to negative 1 based on the basic formulas. So this is negative 2, right? Negative 2 over x squared plus 2 ln x plus c. Okay, so that's number 9. So let's proceed with try this, evaluate the following. So I hope everyone, you have to evaluate that one at home and you have to solve it solely. Do not compare, do not ask someone. After you solve this one, you could compare if your solution, if you got the correct answer. Solve it first before you could have to share it with others. So evaluate the following. This is 1 to 5. God bless everyone. Work at home. And do not forget to subscribe my channel.